Every year, forest fires sweep through the Himalayan foothills, and one of the biggest culprits is something as simple as fallen pine needles. Meanwhile, our cities produce thousands of tons of sewage sludge with nowhere safe to go. What if we could turn both of these waste into something useful at the same time? Hi, I'm Dr. Mohit Aggarwal, ANRF, NPDF at IIT Roorkee, and that's exactly what my research explores. Combining sludge and pine needles and converting them into a clean energy through a process called co-gasification. Let's start with the pine needles. Uttarakhand's Chir pine forest shed nearly 2 million tons of them a year. They are rich in resin, which makes them highly flammable, so they pile up on the forest floor, and in the dry pre-monsoon months, they catch fire easily. In 2016 alone, the state saw over 2k forest fire incidents. Most of this pine litter simply burns away. Sewage sludge is a very different problem. Our treatment plants here at IIT Roorkee produces it in large quantities, and disposing of it is simply very difficult and costly. So we have two very different waste, and my research asks whether we can bring them together and turn both into energy. What is gasification? It's a process where we heat a material at high temperature with only a limited supply of air. Instead of fully burning, the material breaks down into a combustible gas we can use as fuel. Now, sewage sludge is very difficult to gasify on its own. It has a high ash content, and that ash tends to melt and clump together in the reactor, which disrupts the process. This is where pine needle comes in. As a woody biomass, they have low ash, high energy content. Blending them with sludge dilutes the ash to a manageable level and improves the quality of the gas. And there is more to it. The biomass also acts almost like a natural catalyst, helping the sludge convert more completely. So the two wastes don't just add up, they work better together. So how does this actually work in practice? It begins at the treatment plant, sewage treatment plant, where we collect the wet sewage sludge and bring it back to our facility. The sludge is far too wet to use directly, so we sun dry it for about 2 days in the summer sun. We don't dry it fully though, it just needs to reach a workable moisture level before the next step. The next step is pelletization, and this is where most of our time went. The tricky part is moisture. If the sludge dries out too much, it turns rock hard, hard enough to choke our pelletizer, which wasn't really built for a material this demanding. So the whole process comes down to holding the right moisture, around 10 to 15% in our experience, and feeding it slowly. One thing that did surprise us, we never needed a binder. The sludge holds together on its own. The pine needle we source as ready-made pellets and blend the two together in our chosen ratios. These blended pellets then go into a downdraft gasifier fed by a blower. Following the same principle I mentioned earlier, the limited air means the material doesn't fully burn. Instead, it becomes syngas, made up mainly of hydrogen and carbon monoxide. This syngas is fed into an engine coupled to a gasifier. Which uses it to generate electricity, taking us all the way from waste to usable power. We run the system at 3 engine power levels 1.5, 3 and 4.5 kilowatts across different blend ratios, following a structural experimental design, more specifically response surface methodology. For each run, we'll measure the syngas composition and calorific value along with the biochar left behind as a byproduct. The biochar left behind is also useful in itself. One of the objectives of this fellowship is to use it as a low-cost adsorbent for pollutants. Though which direction we take is still open, it could be used to remove emerging contaminants such as PFAS from water or to treat polluted soil. That's something we'll explore as the work develops. Either way, the idea that a single process could do three things at once: manage waste, generate electricity, and help clean the environment. There is also a practical advantage in how local this is. The sludge comes from our own campus, and the pine needles they come from the nearby forest. So this could work as a decentralized on-site solution, particularly for hilly regions where transporting waste is difficult, while also helping reduce the fire risk that pine needles create each summer. We are still early in this work, only a few months in, but as we complete these experiments, we hope to show that two of our most stubborn waste problems can become a source of clean energy and even a tool for cleaning up pollution. I'd like to thank ANRF for supporting this fellowship, IIT Roorkee for hosting the work, and my mentor, Dr. Pratham Arora, for his guidance. Thank you.